The following program is a production of Pioneer Public Television.
Welcome to Compass. I'm Les Heen. This week we look at a fast-growing competition that's in many of our communities and schools. Robotics teams include local mentors, teachers, community sponsors, and students in the process of designing, building, and demonstrating robots. It takes a lot of skill and teamwork to do it, and we have a couple of folks here to tell us about it. We have with us Corey Applegate, who is with the Granite City Gearheads team from the St. Cloud area. And we also have Ryan Swanson, who is competing in Becker and lives there today. Ryan, Corey, thanks for coming to Compass.
Thanks for having us here.
This is an exciting topic, I think, because there are so many people who don't understand how big a deal robotics has gotten to be. And we're in Minnesota, we always talk about the state of hockey, right?
Yes.
But I understand robotics, there are more robotics teams than there are hockey teams at the high school level. Corey?
Yes. The statistics, that I don't have the exact numbers offhand, but there's roughly 100 to 150 more robotics teams in Minnesota than there are high school boys varsity teams.
Yeah. And when we talk about robotics, for a lot of people it may be difficult to understand what this is, but in your case, in the what's called the FIRST robotics competition, you have defined sizes and tasks. Tell us how you start building these robots.
Well, each year in January, FIRST Robotics releases a game or a task in the form of a game where we have to build a robot. Our constraints, so all teams are equal, we have to fit inside of a certain parameters, and this year happened to be 33 by 28 by 4.5 feet tall. And the robot must weigh under 120 pounds without battery or bumpers. So all teams use the same motors and controllers, but beyond that, the design is all up to the team of how they're going to use those parameters and what mechanical parts are going to make.
So largely a square base, and then you can build it up from there. So it's not much different than, let's say, the size of this table.
Yes.
In terms of the footprint, but then it may be 2 feet high, it may be 3 feet high, it may be 6 feet high.
You have choices like what kind of drivetrain. There's lots of different wheels choices to make, and each choice has their benefits and their disadvantages. And then on top of that base, what kind of different manipulators are you going to use to manipulate that year's game object?
Yeah, everything is a strategic design. There's trade-offs with everything. Along with that kickoff, which is the first Saturday in January, there's a 70-plus page manual that comes out with 40 different game rules, 40 different robot rules. It's all very intricate. There's a lot of strategy involved with everything.
Because, for example, Ryan, in the last year, you've become a mentor to local teams since you've competed.
Right.
In this last year, for example, there were sort of lime-colored wiffle balls that were being used, and you had to put those balls in the air. And so tell us, just for example, about the last year, what you had to do, what you had to make the robots do.
Yeah, so the 2017 FIRST Robotics Competition game, Steamworks, the objective, there were 2 different objectives, and they were different. So the first objective is you had these gears, these yellow gears. You had to put them on what they call the peg, which is just a 12-inch long spring. And the students would pull that spring into the airship, and the goal was to get 14 of those gears into the airship. And the more gears you got, the more points you got. It was a tiered system. The other objective was to shoot these wiffle balls into what they call the boiler. And it's like you're putting, the wiffle balls were called fuel, right? The goal is to launch the fuel into the boiler to kind of stoke the boiler. And the more fuel you got, the more points you got. And the objective of the game, obviously, was to get more points than your opponent. And there were different things. For example, there was a ranking point for if you got a certain number of wiffle balls into the boiler, and there was a ranking point if you got a certain number of gears into the airship. And the goal at the end is you get 2 ranking points for a win, and then you get additional ranking points for doing certain objectives.
So when this is announced, you've got mentors, you've got students, you've got coaches, you've got people sitting together watching this, and then they have to step back and say, okay, This year's task is completely different from last year's task.
And they're different every year.
And they're different every year, so you're all watching it together. Okay, now what do we do? What do we do to start building this thing? What's the next part of the process?
Yeah, so I'm actually the strategy mentor for Team 4607 out of Becker. And it's actually my job as the strategy mentor to coalesce all of these ideas that all these students are having and kind of turn it into something workable that we can hand off to the engineering team so that they can build on it, right? So day one, for the past few years, I've actually been involved with a project called Robot in 3 Days, where I've been working with a team of college people, college mentors, to build an entire FRC robot in 3 days. It reduces the build season from 6 weeks down to 3 days.
We didn't touch on that. The build season is 6 weeks long. So from that point, every student from around the world, there's over 3,000 teams around the world, have that same 6-week period to design, build, and program their robot to perform that year's task.
Right.
And on the last day at midnight, teams have to put the robot in a bag, seal it with a tag number, record that number, and they're not allowed to work on that robot until they get to competition.
Right. It all becomes buttoned up, and then you load it in the van and go to the competition.
So his robot in
taken
3
out.
days, these college students, they try to do that task in 3 days. And it's quite literally 3 no sleeping hours.
72 hours,
And
no sleep.
what they do is for a lot of low resource teams is they then release their robot on day 4. And here's what we did. Now you guys go build it better than we did. So
Exactly.
Yeah. Well, and of course, people who love competitions of any type look at how do they continue in the competitions after. So you competed in high school at Becker for 2 years.
Yep.
And whereas Corey, you came to this as someone who was interested in really helping and mentoring, and you came to this world of robotics quite differently, didn't you?
Yes, I had my son somewhat involved through the grade school, some of the smaller robotics projects, and when he got to high school, I was like, you really need to do this, you're a smart boy, smart kid. And I've had 20 years as an electronic controls technician, so I work in the industry in robotics and automation, and it's like, this fascinates me. We got involved, and about 3 weeks into the first season, the main coach for the team that we were part of had to step out, and they kind of handed me the reins. Excuse me. So it was a wild experience, but it's been a great time. 3 years into it now, I keep on chugging along, and our team has actually improved quite a bit because it's all about the mentorship you have. And they were a low resource team that didn't have quite the knowledge. Sure. Well, I brought that in there, helping the students learn those skills. And with that, all these teams in the area have recognized that, and we've been brought into a robotics hub, and we help over 17 teams in the central Minnesota area improve their skills as well.
Right, so the Central Minnesota Robotics Hub, CMNRH, is the greatest thing that's happened to Central Minnesota robotics in ever, I think. It's 17 teams, like Corey mentioned, that are working together and collaborating throughout the build season. So we're competing with each other. We're going to go to the same regionals and compete to be the winner of that regional. However, during the build season, we're sharing ideas, we're giving each other feedback, and from that, we're all becoming stronger teams.
If I have a problem, I'll go in there, and another team from the outside looking and say, well, here's the solution. Oh, and it's so obvious. And the same thing, they may have a problem, and we may have an idea how to get them past that.
And that cooperative spirit, I know from having been at these competitions, extends through to competition day itself, because as the kids are in what they call the pits, a racing
The
term.
greatest experiences in the pits. The past 2 years for sure, there's been rookie teams that come there with nothing but a robot chassis base that could maybe not even drive. And before their very first even qualification match, that robot is performing aspects of the game, and teams from all over the pits are in there injecting and helping and building, putting parts on their robot and helping them one-to-one. So when they get out to the field, they can be as competitive as the next.
And I think it's important. You mentioned that there's a hub of activity, and in your case, Corey, with Granite City Gearheads, in your case, it's not a school-based process, but it's actually kids from multiple schools working together on the same team.
Yes, there's kind of 2 teams out there. There's the school-based team, which is primarily that school, and they run under usually their tech ed departments. Our team is a club, so we actually draw students from multiple schools, up to 7 high schools and homeschool students. And as a club, we're given a little bit more leeway on some of the things that we can do and how we get to competitions. But there also comes with that is a struggle of actually acquisitioning students. We don't have a teacher in the classroom one-on-one with the student saying, hey, you're really a brilliant student, you really need a challenge, why don't you come check out this team? So we don't have that connection necessarily. So that's been a struggle of getting our numbers up.
Right, and as you mentioned all these different tasks, there are obviously different skills that people would bring to it. You mentioned you're an electronics technician. And I know you worked on strategy. And there are, of course, computer designers, or computer programmers rather, CAD people who have to work on, once this thing is put together,
Well, the concept,
Concepts,
get it on paper so
yep.
we can build it.
Right.
yeah, they've got to build it. And then at the competition, they've got to be the ones who drive it. But before then, and here's where the prop comes in, I'm just going to hold this up a little bit in front of you, Corey. This is an example of what a fabricator on a team would do, right?
Yes.
With this, we've got aluminum here with holes drilled in it to reduce the weight. So tell me about this is the kind of work that you've got people doing, right?
So before this, we were actually using 2x4s and raw nails and trying to see if this is going to fit the part. And we decided on a design by using Robot in 3 Days designs and some iteration of ourselves of how we actually going to make what we see on TV. And we prove the fact out, and then we take some raw aluminum after the CAD draws. Here's out of wood. CAD puts it into a 3D model on the computer. And we can go to one of our sponsors, and they helped us machine all the holes in their CNC machine and put all the holes exactly where we needed to fit all the parts together.
Sure, and with the cost of raw aluminum, you'd want to make sure that you prototype this in something else first. That's a big part of it, right?
And that's where our sponsors, we don't have, our sponsor Alexander Industries has donated a lot of, tons, almost at maybe hundreds, that might be exaggerating, of pounds of aluminum. So we can iterate, and if we do make a mistake, it doesn't quite hurt the wallet quite that bad.
Sure. So if you have someone, a student who's maybe not the best at electronics, but he's a wizard with welding aluminum, which is very challenging, there's a place for him on this kind of a
That's a
team.
huge asset to a team. One of the biggest, actually. If you could weld aluminum as a team, that's massive.
It actually goes beyond the robot. There's a saying out there, First Robotics is more than robots. We have web designers, photographers, bloggers, people that have no interest in the mechanical aspects of robotics, and maybe just that's not their aptitude, but they want to be even reporters or public affairs or business. There's spots for those students on a team.
Fundraisers. I know I've
That's
heard of
where the
fundraisers as well, because
The
of
business
course,
aspect, going out there, banging on doors and talking to CEOs and explaining, here's what we're doing, and showing them and asking for help.
Right. Becker has roughly 50 students on our team, and maybe only half of them actually interact with the robot at all. We've got a very strong marketing team, a very strong, what we call awards team. There are many different awards that you can do within the FIRST Robotics competition. And roughly 25 kids are just purely dedicated on fundraising and the business side of things. Each team, and this is what I really love about the program, each team is run kind of like a small business. And as somebody who's kind of gone into the small business world, I can say the parallels are ridiculously, it's crazy. I've learned so much through the program as a student and a mentor beyond just technical skills. Interpersonal skills and talking in front of people is one of the biggest, I would say.
Sure. So you mentioned that you've gone into business yourself, and we should point this out, that your business decision, post-high school, post-robotics team, your robotics experience has influenced what you're doing now. Tell us what you're doing.
Yeah, so I'll give you a really brief story here. So I graduate from my high school team in 2014. I go up to North Dakota State University, and Fargo has got a really great entrepreneurship community up there. The people there are incredible. And kind of through my history with robotics and getting into Fargo, getting into that community up there, I founded a company called Core Robotics. And the purpose of the company is to run summer robotics camps in coordination with FIRST Robotics teams from around the state and hopefully in the future around the country to run summer camps for 3rd to 8th grade students. And the goal for the camps is to introduce the students to the equipment that is used in FIRST competitions like FLL, FIRST LEGO League, and FTC, FIRST Tech Challenge. I use the same equipment that they use during the tournaments in the camps, and I'm introducing schools that don't currently have FLL and FTC programs. I'm introducing it to them, and teams that do have those programs, I'm getting the kids kind of fed into those programs. So the company was derived out of my passion for the program, and my goal is to try to drive more people into the program so that they can experience what I experienced and be impassioned to go into a STEM field when they graduate.
Yeah, and I know you'd mentioned Legos, and that brings us to the other prop that we have here, because I know even at the more serious competitive levels, not at the 3rd to 8th grade, but as you get into more serious competitive levels, you said you might start with wood, right?
Yes.
And you might also start with
Plastic, paper,
with
cardboard.
Legos. I'm just going to hold this up briefly here, but this is an example of a scissors mechanism.
So we talked about last year's game where we picked up wiffle balls. This year's game was slightly different, and we had to iterate and pick up these cubes that were essentially milk crates. We had to lift them up to 7 feet in the air to put them on a scale or a teeter-totter to earn points without getting too deep into the game. And with the students where you're sharing ideas and how do you get your idea out of your head and on the desktop so other people can see what you're seeing. Now CAD is one option, but some people just can't visualize in that world. That's where the prototyping comes in there. And we built this week 1 or 2 and said this is an idea that we could possibly build for a robot. We have our drivetrain, which is Mecanums. That's a whole discussion on its own of how Mecanum wheels work. We're going to use Mecanums. We're going to have an intake system with rolly grabbies on there that could tip the cube up and down. We're going to have these claw mechanisms to do the end game, and we're going to have the scissor mechanism to lift this up. And the neat thing we discovered here is we didn't have to go up that high because just the natural of the scissor system, it angled the cube all by itself, so we didn't have to actually pivot it controllably. So just with this prop, we're like, I think this is what we want to build. So then we started really iterating and making parts, testing parts, driving towards this design and our final design. And Ryan can contest our robot. If you can go to our websites where I have a team of people videoing and posting videos of our robot performing, you'll see this robot performing.
I want to jump in here. So I can attest, as somebody a team that's competed with this guy at the World Championship, we were on the same alliance at the World Championship, which was super cool, and against him at our regional. This is uncanny how close, like if they built this week 1 or week 2, it's uncanny how similar their robot ended up to this Lego model. It's crazy.
Well, and that's, I mean, because this looks very much like the sort of design you'd have on a man lift, is in construction. But what's fascinating too is you look at what the different solutions people come up with. They may use springs, they may use heavy weights, they might use a combination of those. They may use, commonly 12-volt batteries, I suppose, to drive a lot
That's
of the
a
equipment.
requirement for the
We have
competition.
every team has used the same battery.
Yep.
Yeah. So.
Yeah, and so you'll see these, when you go into the pits, you'll see these racks of batteries there, and somebody's got responsibility for charging the batteries because the batteries are going to be powering the robots. And then you may also have, people come up with some wildly creative things.
Yes, that's the great thing with the robotics, is especially FIRST Robotics, is you go into a pit and you're not going to see the same robot. Like you go to a NASCAR race, you're going to see the same car. You go to a baseball game, everyone's going to have a bat and a glove. And here you go in here, and this robot's so much different than that robot, and they're competing and they're performing at the same levels. This year, a lot of elevators, forklift elevators, and single arm robots out there, along with some other really creative, like, why didn't I think of that? So you put that in your book. You said, remember that team, take a picture of it. There's a team I've seen online that were at our World Championship and said, I got to go see that robot. How did they do that? And I went over there and said, I've been fanboying your robot for 6 weeks now. I just couldn't wait to come and see it. And they kind of tell you the story of how they came up with that idea. And it's like, put it in our catalog and said, if another game utilizes a concept like that, we might be able to iterate or bring that into our own robot. Yeah. And like with FIRST Robotics, anything we do outside of the season, we have to publish online so any team can copy our code, copy our designs, and use it themselves too. Otherwise, because we have that 6-week design period, that's when we can have our IP, our intellectual property, to ourselves. But after that, if we want to use it again next year, we have to release all designs so other teams can improve their skills as well.
So I want to make one quick point. There's a very common rule within FRC that you don't build scissor lifts.
First robotics competition, FRC.
First robotics competition, that you don't build scissor lifts.
I never heard that until after we built our scissor.
It's just something that you don't do because they never work and it's just a headache. But these guys made it work, and I think it's the only functional scissor lift that actually did what it was supposed to do that I've seen in my 6 years in the competition.
And why that is a lot is we did this in Stronghold 2 years ago as well. We built a scissor and it didn't work. We had struggled with it. And when we came back to the board this year and said, do we want to do that again? And we shouldn't. I said, but we know what didn't work. Why don't we fix those problems and try it again? Yeah. And it proved to be very successful for us this year. Will we do it again? I have a few people on the team, my son being one of them, that says, even if next year's game called Scissor Works, we're not doing this again.
Maybe that's why they have the rule.
Yeah. So.
But kind of going back to what he was touching on about like sharing information and all of that, in the FIRST Robotics competition, there's the season where it's the build season and then the competition season. When all that's over, after the World Championship, they call it the off season, all right? And one thing that we've got going really, really well here in Minnesota is off-season competitions and off-season training events. So we both attend an event called Jumpstart, hosted at St. Cloud, and
First week of December.
first week of December, right? And basically, it's like 30 plus teams all go there. They all give presentations and they're sharing information. So, Corey, you're giving a presentation at Jumpstart this year, right?
This year I'll be doing, I'm sure scheduled one, but I'm sure it's going to be 2 or 3 sessions on the new Limelight camera system. Team 987 out of Las Vegas, the High Rollers, has developed an FRC vision tracking system all in one kit. And in the past, that's been difficult. You need a processor, a camera, and the software to run all that to track apart. They built this all-in-one device, and our team was beta tested it last summer. So we were one of the first people to expose to it, and it's kind of blowing up in the FRC community, this device. So I've been tasked since we were beta tester to actually have a class or two at Jumpstart on the Limelight and how to use it. And this class is going to be on Friday night likely, so it's going to be hands-on, one-on-one. I currently have 2 of them, and I have access to 1 or 2 more. So we may have 4 working models in this class where students can actually touch it, program it, and track objects, at the class.
And one of the things I think that's interesting, Corey, is you talk about these, these all bunch of schools in your case, or Ryan, in your case, there was one school. In some cases, we have situations where there are very big schools that have got lots of sponsors and they're doing very well.
Yep.
And I know there was a story that was in the news recently about Greenbush, Minnesota, very small town, that has done extraordinarily well. So what we're seeing is a leveling of the playing field, whereas if you've got creativity and the basics, the size of the school doesn't necessarily matter. There's some amazing schools doing well.
Industries have identified that the students or the workforce coming out of the school right now, they haven't been on the farm, they haven't been under the hood, they don't have that what is it?
Small town.
Well,
that
critical thinking.
critical thinking.
On how to solve a problem. Where out in the rural communities, that is life. A big hammer and a stick welder, and you can fix a tractor. It might be a little stereotypical, but there's some truth to it that the students coming out of there have that critical thinking. So these small town communities with these small groups of students are competing with the big guys and doing very well with them, just with that critical thinking level and the level of just the way FRC is put together to make sure the field is as level as possible.
Well, because an important part of small town life and farming in particular was if we have a problem, let's build something to solve the problem.
Right.
So that is where a lot of people grew up in small towns, as you said. Traditionally, that was a big part of it. We got a problem. What do we build to fix this? How do we do that?
Right.
The YouTubers today, they want to pull their phone out and just needs to work. Where back in I want to know why that works. Show me the software. Show me why that's going. How can I do it myself?
Yeah, obviously this touches on STEM in schools. We should touch on that as well, of course. That there's a lot of interest in STEM education. And part of that STEM education is that it's not just a select group of students taking an interest in technology and building and fabricating, but it's really a much broader group of students. So we're looking at reaching out to all kinds of students from all kinds of places. We're looking at young men and young women from all across, inner city schools, rural schools. Are you seeing more and more of that as the competition develops? I mean, Corey, Ryan, you've been in this a few years.
Yeah, so I can talk a little bit about the development of the Becker Robotics team because I've seen it firsthand. My rookie year, back in 2013, we had, I want to say it was like 13 kids on the team or something like that, 12 guys, 1 girl. Fast forward to 2018, this past year, we had more than 50 kids on the team, and more than 50% of them were girls, and we have a girl named Victoria. I don't know if I'm allowed to say her name, but Victoria manufactured our entire robot. We have a mill from like 1917 or something crazy.
She's a brilliant mind. Yeah.
She is going to be making so much money in the future in a trade, most likely. And it's just insane. Like we have a 1917 mill, and she made our entire robot on that mill, and it's amazing for me to watch.
Well, we've only got a couple of minutes left, so I want to touch on for those people who are students or teachers or someone who knows a young person that says, oh, I think I've got a nephew or a son or a daughter who might really want to build something. How do they start learning about where to go and learning about robotics? I'll start with you.
Well, the first thing is check we have a website, so find somebody that is on the inside. They can definitely get you in touch with a local team. That's been our problem, is how do we get people. The one thing that we always tell people, you don't need to know anything. We're going to teach it to you. It's hands-on, it's one-on-one. If you have an idea but you don't know how to get to that idea, a mentor is going to be there and said, come with me, I'll show you how this is done.
And many schools have the team, so as they get into high school,
it's there. Like for us, you can go to the GrandCityGearheads.com. there's some contact information there and how to find us. Our build times and when time we meet, we're open shop. Anybody, any team, any mentor can come in during our meeting times, and we will invite them in and show them how we work. And likewise, if I know Becker or somebody else is having a meeting, I may drop in and just see what they're up to, and it's open door.
Your advice?
Yeah, so for anybody in Minnesota in particular, you can just go to Google, type in Minnesota First Robotics. Minnesota First has a great website you can go to. They've got a ton of information. There's a guy named Ken Rosen that you can reach out to, and we can get his email out there. But if you're outside of Minnesota watching this, I would say go to a website called firstinspires.org. That is the website for the First Robotics competition. They have a map that can introduce you to teams, and it's a very useful resource.
I know I love robotics. I've been to the competitions. It's great fun, but we're out of time here. So we have to stop here. Corey Applegate of Granite City Gearheads and Ryan Swanson from Becker, thank you both for being on Compass.
Thank you for having us.
Thank you very much.
That's all the time we have for this week on Compass. Thanks for watching. See you next week.